Right, this is the 14A. This is the review of the previous week. Just a reminder, there is a homework assignment, a notebook check, and an activity due this week. No synchronous lessons, no office hours. This announcements. So that's a leftover from last, but there are no additional announcements that need to be made at this time. The weekly plan, remember, just Monday is more of an introductory and day for notes. Friday is a miscellaneous for the homeworks end. 3 days in between will be for lessons and labs. All right, lab activity, homework, notebook check due every week. So this is the checklist that you would need to complete every week, and you need those codes in order to move on. But as an incentive, I give you those codes to move on with the assignment. I'll give you the codes on Friday if you're on Friday. But if you want to complete it early or you're not here on Friday, you're going to have to watch those extra videos. So let's review what we learned this week. So we learned about So we learned about temperature, right? So temperature is a measure of the average kinetic energy of the atoms and molecules. So it's just the movement of those molecules. And what is cold? Well, cold is just that kinetic energy moving from higher kinetic energy to lower kinetic energy. So when you drop ice into water, well, cold isn't moving out into the water. What's happening is that ice has lower kinetic energy. The higher kinetic energy is like giving some of that energy, kinetic energy, to the ice cubes. And then we did the state of matter activity, in which you were supposed to get this out of the, with whether they're rigid, fixed shape, or fixed volume. Then we said, well, what is that fourth state of matter? Plasma. Well, plasma is nothing more than ionized gas where electrons have been ripped off the atom. It's the most common state of matter in the universe. So those are the links for today. Well, the next day we opened up with Revenge of the Pith, that lab where we did the same experiment that Charles Duffay did. Now, why does a balloon stick to one's hair? So we came up with this, right? Electrical conductors allow for the flow of electricity. Electrical insulators do not allow for the flow of electricity. And this is the law of conservation of electrical charge. So charge can either be created or destroyed. Charge can only be transformed from place to or transferred from place to place. The total amount of charge in the universe is fixed, and the big fundamental rule is like charges repel and unlike charges attract. That's the key to all of this electrostatics. So electrons are easy to remove from the atom. Electrons get transferred from one object to the next. Protons do not get transferred in any of the reactions. If the object gains electrons, then it becomes negatively charged. If an object loses electrons, it becomes positively charged. So polarization is the process of separating opposite charges within the object. Electrons do not get transferred during polarization. So that was the aluminum can demonstration that I did. And you can see that in that simulation. All right, then we have charging by friction, in which electrons are transferred by rubbing objects together. And you can see that in that simulation, but also these graphics over there. Electrons are being transferred by rubbing objects together. Now, charging by contact or conduction is a process of giving one object a net electric charge by placing it in contact with another object that is already charged. So if you look over to the graphic to the right, you can see that I have a negative charged PVC pipe, and it's going to touch like a metallic ball, and those negative charges spread out along the ball because they are getting away from each other, right? Because they are the same charge, they are repelling each other. Then we have charging by induction. This is the complicated one. It's bringing a charged object near but not touching the neutral object. Then the object will be grounded to either take those excess electrons away or add electrons depending on the charge of that rod. Now, what is grounding? Well, grounding is a process of transferring any excess charge of a charged object to another object of substantial size, which is Earth, provides a pathway for electrons to or from Earth. So you can see that you can ground either positive or negative. If it's positive, electrons flow from the ground to the charged object. If it's negative, it provides a flow of electrons. And lightning is a form of grounding, and you can see that in that simulation. And the last one we had was we did the static cling lab. This was the answers that you should have gotten for the static cling lab. And what determines what object gains and loses electrons when charging by frictions? And it's a triboelectric series. It's a list of ranked materials according to their affinity towards electrons. So charging by friction is also called triboelectric charging. What this means is that different materials want electrons more or less than other materials. Materials towards the lower bottom of the list have regular affinity or love for electrons and have the tendency to go negative. The materials towards the top have a smaller affinity or love for electrons and have the tendency to go positive. Two objects are being rubbed together. The material lower on the list will gain the electrons and become negative. So at this time, this is the 14A verbal code, written code. I would recommend you write this down somewhere. All right, so what are we learning about this week? Inverse square law, electrical potential, survival skills, electric current. So this is a video on the inverse square law. This is the video on Coulomb's law. At this time, I'll give you the verbal code. It is 304. I say that again, the verbal code is 304. This is the video on current. This is a lab we're going to do on Coulomb's law. This is a lab we're going to do on Ben's mistake. So it's about current. And there are the links for today. And as always,